right. All right. We should be good. All right. Hello. Once again, I appreciate you for joining me again this evening. Welcome back into the stream. Welcome back in. Um, Hope you're having a wonderful day so far. Let's go ahead and get this show on the road. All right. And there we go. All right. Cool. Let's go ahead and get started here. All right, let's go ahead and get going. Hello, everybody. Welcome back into the channel. My name is Michael, and I hope you're having a wonderful day so far. Today, we're going to be jumping back into C Programming, A Modern Approach by K.N. King, second edition. We are going to be in where are we? We are going to be jumping in and tackling chapter 5 today, so super excited to get into it today. Chapter 5, selection statements. So this should be on selection, iterations, and jump statements. Super excited to get into this one. If you'd like to join me live, this is the condensed version of the stream. If you would like to join me live, I stream every single day around 7 p.m. PST, where you can catch myself learning, where you can join me learning computer science and programming almost every single day. All right. Hello, everybody. For those that are here on, that was a chopped intro. I got to redo that. Sorry, everybody. We got to go through the cringe, everybody. All right, we got to go through the cringe again. Hello, everybody. My name is Michael. Thanks so much for joining me. I hope you're having a wonderful day so far. Today, we are jumping back into C Programming, A Modern Approach by K.N. King, second edition. All right, got that. Now let's go up to here. Things you got to do, guys. Bear with me. All right. We're going to be jumping into Chapter 5 today, selection statements. I'm super excited. This is the condensed version of the live stream where I teach myself computer programming and computer science almost every single day. If you'd like to join me, consider joining me on the live stream. Man, I cannot talk. All right, that's good enough. I'll chop it up. Oh, God. It's over. Let's chill. Okay. Let's jump right in. Yo, what's up, watcher? How's it going? JB, what's going on? Okay, let's dive on in today. Chapter 5, or C Programming, A Modern Approach, Chapter 5, Selection Statements. Programmers are not measured by their ingenuity and their... Programmers are not to be measured by their ingenuity and their logic, but by their completeness of their case analysis. I cannot talk today, you guys. This is going to be rough. Programmers are not to be measured by their ingenuity and their logic, but by their... Oh my gosh. but by the completeness of their case analysis. Although C has many operators, it has relatively few statements. We've encountered two so far, the return statement and the expression statement. Most of C's remaining statements fall into three categories depending on how they affect the order in which statements are executed. Selection statements. The if and switch statements allow a program to select a particular execution path from a set of alternatives. Iteration statements. The while, do, and for statements support iteration, looping. Jump statements. The break, continue, and go to statements cause an unconditional jump to some other place in the program. The return statement belongs in this category as well. The only other statements in C are the compound statement, which groups several statements into a single statement, and the null statement, which performs no action. This chapter discusses the selection statements and the compound statement. Chapter 6 covers the iteration statements, the jump statements, and the null statement. Before we can write if statements, we need logical expression, conditions that if statements can test. Section 5.1 explains how logical expressions are built from the relational operators less than or equal to, greater than, and greater than or equal to. The equality operators equals to, and not equals to, and the logical operators ampersand, ampersand, bar, and exclamation point. Section 5.2 covers the if statement and the compound statement, as well as introducing the conditional operator, question mark, colon, which can test a condition within an expression. Section 5.3 expresses the switch statement. Okay. 5.1 Logical expressions. 5.1 Logical expressions. Several C statements, including the if statement, must test the value of an expression to see if it's true or false. For example, an if statement might need to test the expression I is less than j. A true value would indicate that I is less than j. In many programming languages, an expression such as I is less than j would have a special Boolean or logical type, such a type would have only two values, false and true. In C, however, a comparison such as I is less than j yields an integer, either 0, false, or 1, true. With this in mind, let's take a look at the operators that are used to build logical expressions. Relational operators. C's relational operators, table 5.1, corresponds to the less than, greater than, less than or equal to, and greater than or equal to operators of mathematics, except that they produce 0, false, or 1, true when used in expressions. For example, the value of 10 less than 11 is 1. The value of 11 less than 10 is 0. The relational operators can be used to compare integers and floating point numbers with operands of mixed types allowed. Thus, 1 less than 2.5 has the value of 1, while 5.6 less than 4 has the value of 0. The precedence of the relational operators is lower than that of the arithmetic operators. The precedence of the relational operators is lower than that of arithmetic operators. For example, I plus j less than k minus 1 means I plus j in parentheses less than k minus 1 in parentheses. The relational operators are left associative. The expression I less than j less than k is legal in C, but doesn't have the meaning that you might expect, since the less than operator is left associative. This expression is equivalent to I less than j in parentheses, which is less than k. In other words, the expression first tests whether I is less than j. The 1 or 0 produced by this comparison is then compared to k. The expression does not test whether j lies between I and k. We'll later see in this section that the correct expression would be I less than j and j less than k. Equality operators. Although the relational operators are denoted by the same symbols as in many other programming languages, the equality operators have a unique appearance. Table 5.2. The equal to operator is two adjacent equal sign characters, not one, since a single character represents the assignment operator. The not equal to operator is also two characters, exclamation point and equal sign. Like the relational operators, the equality operators are left associative and produce either 0 for false or 1 for true as their result. However, the equality operators have a lower precedence than the relational operators. For example, the expression I less than j, which is equal to j less than k, is equivalent to I less than j in parentheses is equal to j less than k in parentheses, which is true if I is less than k, which is true if I is less than j and j is less than k are both true or both false. Clever programmers sometimes exploit the fact that the relational and equality operators return integer values. For example, the value of the expression parentheses I is greater than or equal to j parentheses plus parentheses I is equal to j parentheses is either 0, 1, or 2, depending on whether I is less than, greater than, or equal to j, respectively. Tricky coding like this generally isn't a good idea, however, it makes programs hard to understand. Logical operators. More complicated logical expressions can be built from the simpler ones by using the logical operators and, or, and not. Table 5.3. The exclamation mark operator is unary, while ampersand ampersand and bar bar are binary. Symbol, exclamation mark, logical negation, ampersand ampersand, logical and, bar bar, logical or. The logical operators produce either 0 or 1 as their result. Often, the operands will have values of 0 or 1, but this isn't a requirement. The logical operators treat any non-zero operand as a true value and any The logical operators treat any non-zero operand as a true value and any zero operand as a false value. The logical operator behaves as follows. Exclamation mark expression has the value of 1 if expression has the value of 0. Expression 1 ampersand ampersand expression 2 has the value of 1 if the values of expression 1 and expression 2 are both non-zero. Expression 1 bar bar expression 2 has the value of 1 if either expression 1 or expression 2 or both have a value of non-zero. In all other cases, these operators produce the value of 0. Both ampersand ampersand and bar bar perform short-circuit evaluation of their operands. That is, these operators first evaluate the left operand, then the right operand. If the value of the expression can be deduced from the value of the left operand alone, then the right operand isn't evaluated. Consider the following expression. I not equal to 0 and j divided by I is greater than 0. To find the value of the first expression, we must first evaluate if I is not equal to 0. If I isn't equal to 0, then we need to evaluate the next expression. J is divided by I is greater than 0 to determine whether the entire expression is true or false. However, if I is equal to 0, then the entire expression must be false, so there's no need to evaluate the right side. The advantage of short-circuit evaluation is apparent. Without it, evaluating the expression would have caused a division by 0. Be wary of side effects in logical expressions. Thanks to short-circuit nature of the ampersand ampersand and bar bar operators, side effects in operands may not always occur. Consider the following expression, where I is greater than 0 and plus plus j greater than 0. Although j is apparently incremented as a side effect of evaluating the expression, that isn't always the case. If I is greater than 0 is false, then plus plus j 0, then plus plus j is greater than 0 is not evaluated, so j isn't incremented. The problem can be fixed by changing the conditional to plus plus j greater than 0 and I greater than 0, or even better by incrementing j separately. The exclamation point operator has the same precedence as the unary plus and minus operators. The precedence of the ampersand ampersand or logical and logical or is lower than that of the relational and equality operators. For example, I less than j, logical and k is equal to m means that we evaluate I is less than j, and if k is less than m, or sorry, and if k is equal to m, the exclamation point operator is right associative. Ampersand, ampersand, and bar, bar are left associative. Cool. All right, cool. It's getting hot here. It's getting hot in here. All right, hold on. So let's go catch up on some notes here. Welcome in, everybody. I hope you're having a good day. I'll be working on the side while watching. Mostly done with Python. Got a few expressions and project to finish, then straight to C. Nice, dude. Hey, TV Josh, welcome back in. This is C Programming, the Modern Approach, 2nd edition. Hey, Arrow, what's going on? Okay, let's go ahead and catch up on some notes here. So we have selection statements. We have iteration statements. And we have jump statements. Right? So a relatively few statements. So these are all different types of statements. So types of statements in C. We'll go here, and then we'll do this. If and switch statements allow for a program to select a particular execution path from a set of alternatives. I like that. Let's kind of give this some syntax here. Cool. The iteration statements, the while, do, and for statements support iteration, looping, right? Can't wait till we get back into looping, till we unlock that again. We're kind of following the path of the book, so in our problems we haven't really been allowed to do looping. All right. And then jump statements, the break, continue, and go to statements cause the unconditional jump to some other place. Ooh. Oh, that's cool. I didn't know that. I didn't know you could do that. Okay. Ooh. The return statement belongs in this category as well. Okay, and then break, go to, ooh, cool. Nice. Okay. The only other statements in C are the compound statement, which groups several statements into a single statement and a null statement. So there's a compound statement, which groups several statements into a single statement. And then there's the null statement, null statements, which performs no action. Hold on, there's something going on with my dishwasher. all good. It's just making a weird hum. It's loud. Hey, how's it going? Welcome back in, everybody. John, that short circuit evaluation is very useful for null checking pointers before dereferencing them. If pointer and pointer is some val, and pointer some val. So check to see if the pointer exists first, and though you don't even do the second conditional. Yeah, we've been doing the short circuit statements in Python. We kind of got exposed to those with some of our leak code problems early on. Okay, so this chapter discusses sections and compound statements. Chapter 6 covers these if statements. Before we can write if statements, we'll need logical expressions. Condition. Okay, so then we have logical expressions here that we read here. So logical expressions must test the value of expression to see if it's true or false. An expression such as what expression, a Boolean or logical type, such as true or false, and see, however, comparison this yields an integer. Okay, cool. So okay, let's do this. Logical expressions. So they test the value of an expression to see if it is true or false. And we'll say in C, a comparison such as this yields an integer, either 0 false or 1 for true. Zero, false, or 1, true. Cool. So then we have these relational operators. Right? So these relational operators, table 5.1 corresponds to the, greater than or less than on all those guys. Correspond to these operators except for that they produce this when using expressions. Correspond to this in mathematics. Can I get this guy specifically? No. How can I copy that one? There we go. Operators of mathematics, except that they produce 0 for false or 1 for true when used in expressions. Expressions. Cool. So let's go ahead and take this guy here for the notes. Let's copy this image in. Nice. If you guys want access to these notes, they're on my GitHub, link down below. That's pretty good notes here that we've been taking throughout the whole book so far. So correspond to these, right? Except that they produce 0 or 1 for being true for 0, 1, and false for 0. So it will probably take me a little bit of getting used to for receiving these values rather than receiving Boolean, object types in Python. Because I usually I'm able to just check if value and it automatically checks like if true or false, or like if like there's stuff in the array or whatever. So it's going to maybe be a little bit, we have to kind of use these some logical operations, it looks like, to in unison, it looks like, or something like that. Okay, so let's keep rolling. So you can check floating point and integers together with these guys. So works for comparing float and int together. Is lower than the precedence of relational operators is lower than that of arithmetic operators. For example, left associative. This is pretty good here. We need this. So the precedence of the relational operators is lower than that of the arithmetic operators. For example, so we'll go like this and do an example. Which is less than means this less than this. And then we're going to do that and go like this. Cool. Awesome. Right, so it just means that it's left associative. So when these are in line with the same precedence, we just work from left to right, in that kind of order of operation. So these have the same precedence. These have lower order than that of arithmetic. So we would do the arithmetic operations first, and then compare it afterwards. Good evening, Tim. Early crew checking in. How's it going, Mr. Tim? Will there be Fortnite tonight? Yeah, if we finish this chapter early and I'm feeling up to it, I'd be down to maybe play a game of League. I haven't played a game of League in a long time. I got it all loaded up on my gaming PC, though. The thing about League, though, is it used to make I had to stop playing like 2 years ago. I really liked playing League, but it would hurt my fingers really bad. I kept getting really bad carpal tunnel in my wrist and hand because of just the constant click. So I'm trying to figure out maybe how we can maybe go about that. Well, maybe we'll try again and yeah. Okay, so is legal, it might have this, but it evaluates to left association first. So let's also, I like this example. So left associative, so we'll do this example, and let's take this one as well. So let's go I less than J, which is less than K. And let's make the, oh, come on, stop doing that. And then this is going to means I less than J, which is less than K. Cool. Nice. In other words, the expression first tests whether I is less than J, then 1 or 0 is produced. And then that 1 or 0 is evaluated against K. The expression does not test whether J lies between these values. We'll see later in this section the correct way would be to do this. Okay, then we have these equality operators. Right? So the equality operators, although relational operators are denoted by the same symbols, we did a read through. Now we're just going back through and doing some notes of these couple of these pages. But I'll probably, let me go up on my notes real quick. Okay, equality operators. Although the relational operators are noted by the same symbols as in many other programming languages, the equality operators have a unique appearance. The equal to operator is two adjacent characters, meaning not one, since a single character represents the assignment. The not equal to operator has two characters, this and this. So these, right, these test equality between two expressions or values. Cool. Let's grab our little chart here. Copy this bad boy in. Nice. Are left associative. They produce either 0 or 1, true or false as their result. So these are left associative and produce either 0, which is false, or 1, which is true as their result. Right, that's fine. However, the equality operators have lower precedence than the relational operators. For example, these have lower precedence than the relational operators. And then we have an example here of ji, which is less than j, which is equal to j less than k. And then this is going to means I less than j, which is equal to, if it's equal to j less than k. There we go. Jeez. Okay. Which is true if both of these are true and both of them are false. Which, right, so this, we're going to say true if both the left and right are are 0, are true, or false. You'll say the entire statement is true if both the left and right are true or false. If both the left and right true or false. Cool. Then we have logical operators. Just catching up on our notes here for the first couple of pages. Bear with me. It's good that we go back through and get these notes because it helps solidify after the first pass. It's like a study technique. So more complicated logical expressions can be built from simpler ones using the logical operators and, or, and not. Okay. More complicated expressions can be built from simpler ones using and, or, and not. Okay. The exclamation mark operator is unary, while the logical and logical or are binary. So the logical negation, binary. Right, so this is say is unary, while the ampersand and bar are binary. Okay, and so if we have this guy here. Copy this right into our notes. Nice. Okay, the logical operators produce either 0 or 1 as a result. Often the operands have values of 0 or 1, but this isn't a requirement. The logical operator treat any non-zero operand as true and any 0 operand as a false value. So logical negation of the expression has the value of 1 if the expression has a value of 0. Returns the value of 1 if the expression are both non-zero. Okay, these ones are a little bit more confusing for sure. So we have this and expression, we'll say, has the value of 1 if the expression has the value of 0. And then we have this guy here. It's expression 1 and expression 2 has the value of 1 if the value of expression 1 and expression 2 are both non-zero. And then this one has a value of 1 if both has a non-zero value. 1 or 2 or both have a non-zero value. These ones are, I'm going to need some practice with these ones for sure. It's a little bit more confusing than Python. Expression 1. Expression 2 has the value of 1 if either expression 1 or expression 2 or both has a non-zero value. In all other cases, these operators produce the value of 0. So then we have this thing called short-circuiting, which we know about. So we'll kind of do this, come down here, short circuit. Circuiting. Within logical expressions, the first expression evaluated can dictate the behavior of the rest, behavior of continuing the rest of the evaluation. And then we'll say example here, where I is not equal to 0, and j is divided by I is greater than 0. Right? This would short circuit, we would say if I is equal to 0, so if I does not equal to 0, right, if I does not equal to 0, evaluates to, if it does equal to 0, false. meaning I is equal to 0, right? Then the right side of the entire expression, the right side, j divided by I greater than 0 is not evaluated. Okay, I'm going to take this and get a little bit of a polish. The demonstration of short circuit evaluation in C. The logical AND operator, and means logical AND. In C, logical AND is short-circuited, meaning that if the left side is false, the right side won't even be checked. So if this evaluates to true, then C continues to check. If this evaluates to false, then C skips this entirely. Within a logical expression, the first if the first expression if the first condition is evaluated. Oh no. Within a logical expression, the first expression evaluated can dictate the behavior of continuing the rest of the evaluation. The first condition evaluated can dictate the behavior. Yeah, I like that definition. How's it going, Dimitri? Thanks for coming in. Arrow, then don't watch. Simple as that. All right, let's keep rolling. All right, here we go. So beware of side effects, right? We don't want side effects to take place because if you have these to happen in the second expression, this might not even happen. The logical negation operator has the same precedence as the unary plus and minus. The precedence of the logical and logical or is lower than the relational and equality operators. For example, this evaluates to where you create logic first and then you do the entire expression together. Okay, so let's say the in this case, then J is incremented. The problem can be fixed by changing condition or even better, incrementing J separately. So this operator has the same precedence as the minor and plus operator. The precedence, okay, yeah, okay, let's take this here. So the operator has the same precedence as my unary plus and minus operators. And then the precedence of this is lower than the relational and equality operators. We like that. So we'll say this and is lower than the relational and equality operators. We'll say it's lower than the, okay, cool. So then we'll give an example here. want this guy here, where we say that I is less than, why does it do that? Less than J, and K is equal to M. And we'll say means that I is less than J, and K equal to M. Cool. Then we're going to give one last little note here and say that this guy is right associative and these are left associative. I do want these because I want to refer back to them. It's right associative, ampersand, ampersand, and bar, bar are left associative. Cool. Beer's coming along great. I know my girlfriend, she gave me crap for it. She said, she was like, but I said it's No Shave November, so we've got to, she's like, oh, okay. So, but I might let it go, you know. We get more views, I think, on a clean shave. People like the younger look. Okay, cool. Let's keep rocking. Sorry, we're catching up. We're just doing our notes here. Okay, I think we're caught up here. Okay, so I'm definitely gonna need some. Practice with these ones, because like I said, I'm not super familiar with. I don't have a lot of practice receiving zeros and ones back for Boolean evaluation, rather than true or false objects like in Python. Now, like our boy Dimitri mentioned, that we do have a standard bool header, and so that sometimes returns some stuff. So that's kind of interesting that we do have some options for dynamism with that, which we'll get to, I'm sure, in the book probably. Okay, let's keep on rolling and get into 5.2 here. Okay, I think I'm gonna try to do my notes a little bit more, not do as much of a gap, because that was a lot of notes. Okay, maybe I'll do it like after each page. 5.2, the if statement. The if statement allows a program to choose between two alternatives by testing the values of an expression. In its simplest form, the if statement has the form if, parenthesis expression, parenthesis statement. Notice that the parentheses around the expression are mandatory. They're part of the if statement, not part of the expression. Also, note that the word then doesn't come after the parentheses as it would in some programming languages. When an if statement is executed, the expression in the parentheses evaluates. When an if statement is executed, the expression in the parentheses is evaluated. If the value of the expression is non-zero, which C interprets as true, the statement after the parentheses is executed. Here's an example. If line num is equal to max lines, line num equals to 0. The statement line num equals to 0 is executed if the condition line num is equal to max lines is true, has a non-zero value. Don't confuse is equal to equality with equal to assignment. The statement, if I is equal to 0, tests whether I is equal to 0. However, the statement, if I equals 0, assigns 0 to I, then tests whether the result is non-zero. In this case, it always fails. Confusing is equal to with assignment is perhaps the most common C programming error, probably because equal to assignment means is equal to in mathematics and in certain programming languages. Some compilers issue a warning if they notice equals to where is equals to would normally appear. Often, the expression in an if statement would test whether a variable Often, the expression in an if statement will test whether a variable falls within a range of values. To test whether 0 is less than or equal to I, which is less than or equal to n, for example, we'd write if 0 is less than or equal to I and I is less than or equal to n. To compare the opposite condition, I is outside of the range, we would write if I is less than 0 or I is greater than or equal to n. Note the use of the logical OR operator. Note the use of the logical OR operator instead of the logical AND operator. Compound statements. In our if statement template, Notice the statement is singular, not plural. If expression, okay, I gotta restart this one, bro. Compound statements. In our if statement template, notice that the statement is singular, not plural. If expression statement. What if we want an if statement to control two or more statements? That's where the compound statement comes in. A compound statement has the form of brackets statement brackets. By putting braces around a group of statements, we can force the compiler to treat it as a single statement. Here's an example of a compound statement. Curly brace, line num equals to 0. Page plus plus. Page num plus plus, bracket. For clarity, I'll usually put a compound statement on several lines with one statement per line. Curly brace, line num equals to 0, page num plus plus. Notice that each inner statement still ends with a semicolon, but the compound statement itself does not. Here's what a compound statement would look like when used in an if statement. If line num equals to max lines, set this line num to equal 0, and then increase the page number. Compound statements are also common in loops and other places where the syntax of C requires a single statement, but we want more than one. So this is just like indentation in Python. I was kind of confused what it was saying up here, but then with the example, I was like, okay, here we go. Just saying like the kind of the if what you want to happen after your conditionals take place or evaluated to true, right? You can have more than one thing happen. Okay, let's kind of catch back up on some notes here. All good, Arrow, all good, no worries. Davey, No Shave November, about to look like GNU logo by the end of the month. I'm about to look. I'm gonna need to get a. I was thinking about getting a ThinkBook, like a ThinkBook like 490S or something, or maybe like an X1 Carbon or something, like $200 on Marketplace, and then we can maybe get Fedora Linux on there, and then really go full neckbeard, huh? Get Fedora Linux. I was thinking about we start doing a home server on Fedora Linux and get into that. That could be a lot of fun on the channel. What do you guys think? The if statement. The if statement allows a program to choose between two alternatives. Let's say the if statement allows a program to choose between two alternatives by testing a value of an expression. Ooh. Cool. Ooh. Nice. So then we have like this example here. Take this right from the book. Copy image. Go here. Parentheses around the expression are mandatory. They are part of the if statement, not the expression. Parentheses around the expression are mandatory. They are part of the if statement, not part of the expression. Cool. It's evaluated the expression in the parentheses evaluated. If the evaluation expression is non-zero, then C interprets it as true. If the evaluated expression, which C right here. Let's go here as the statement and the print after the parentheses execute. If the value of the expression is a non-zero, which C interprets as true, the statement after the expression, after the parentheses is executed. So let me actually take this, put it here. Like that. Get rid of that there. Okay. And then let's do an example here. Oh, so you can just nest like this in an indented for a single statement. Wow. Interesting. I didn't catch that. Okay, cool. You can nest these together. In our if statement template, notice that the statement is singular, not plural. If expression, then statement. If we want to have multiple statements, we can have control, we can do a compound statement. Compound statement. An if statement that controls two or more statements. Right, so we'll say an if statement that controls two or more statements. That's where the compound statement comes in. It comes in this form here. Ooh. Let's take this guy right here. Nice. Like that. Hey! Zishan, thank you so much. ThinkPad plus Arch, by the way. I have a T480S, but I need to replace the battery. You guys have ThinkPad recommendations? I really like the models are so confusing. I don't really know what to get. I want to get a ThinkPad, like a little bit of an older one, but it's still like, and then just that still has some good hardware in it that I can just run like a little home server in and get some, try some stuff out. If you guys have any recommendations, let me know. But I was looking at like Fedora, and Ubuntu, and stuff like that, so let me know. I was doing some research. Okay, so then let me, we'll go ahead and we'll take this example here. Put it down here. Cool. Nice. All right, I think we're ready to move on to the else clause here. The else clause. An if statement that may have an else clause. If expression statement, else statement. The statement that follows the word else is executed if the expression in the parentheses has the value 0. For an example of an if statement, here's an example of an if statement with an else clause. If I is greater than j, then max is equal to I. Else max is equal to j. Notice that both inner statements end with a semicolon. When an if statement contains an else clause, a layout issue arises, when an if statement contains an else clause, a layout issue arises. Where should the else block be placed? Since, gosh, dude, many C programmers align it with the if at the beginning of the statement, as in the previous example. The inner statements are usually indented, but if they're short, they can be put on the same line as the if and else. There are no restrictions on what kind of statements can appear inside an if statement. In fact, it's not unusual for if statements to be nested inside other if statements. Consider the following if statement, which finds the largest of the numbers stored in I, j, and k, and stores that value in max. If I is greater than j, and if I is greater than k, then max is equal to I, else max is equal to k. If this beginning statement isn't true, where I is greater than j, then if j is greater than k, then max is j, else then max is k. If statements can be nested to any depth. Notice how aligning each else statement with the matching if statement makes the nesting easier to see. If you still find the nesting confusing, don't hesitate to add braces. Adding braces to statements, even when they're not necessary, is like using parentheses in expressions. Both techniques help make a program more readable while at the same time avoiding the possibility that the compiler won't understand the program the way we thought it did. Some programmers use as many braces as possible inside if statements and iteration statements as well. A programmer who adopts this convention would include a pair of braces for every if clause and every else clause. If I is greater than j, brace. If I is greater than k, brace, so on and so forth. Using braces, even when they're not required, has two advantages. First, the program becomes easier to modify because more statements can easily be added to any if or else clause. Second, helps avoid errors that can result from forgetting to use braces when adding statements to an if or else clause. Nice. So let's quickly jot down some stuff about the else clause here. The else clause, right? Oh, why can't I spell? What is going on with me today? Okay, an if statement may have an else clause. The statement that follows the word else is executed if the expression in the parentheses has a value of 0. Is executed if the parentheses has a value of 0. So then we'll take this guy here, copy image, paste that there. Cool. So then we have another example here. So then let's just do, like, let's just kind of jot down these examples. I think that's the best way to do it, honestly, is to learn by these examples, because it seems like it's kind of the best, yeah. So you even could, do stuff like this, right? You can even add braces. Right. Just a bunch of examples here for these if-else conditionals. Okay. Zorin OS Omnarchy is the new hype distro. The K&R brace style is painful to read. Almond style is objectively superior for readability. K&R is difficult to read in general, I think. Kernighan and Rich, yeah. What is the almond style, John? Is the almond style with the indents? I'm down for the indents if I don't have to use braces. Braces, I hate braces too, from what I've been using them so far. Okay. Cascaded if statements. We'll often need to test a series of conditionals, stopping as soon as one of them is true. A cascaded if statement is often the best way to write such a series of tests. For example, the following cascaded if statement tests whether n is less than 0, equal to 0, or greater than 0. If n is less than 0, then print n is less than 0. Else, if n is equal to 0, print n is equal to 0. Else, print n is greater than 0. Although the second if statement is nested inside the first, C programmers don't usually indent it. Instead, they align each else with the original if. If n is less than 0, print f n is less than 0. Else if print f n is equal to 0. Else print f n is greater than 0. This arrangement gives the cascaded if a distinctive appearance: if expression statement, else if expression statement, else if expression statement, dot 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 dot, else statement. The last two lines, else statement, aren't always present, of course. This way of indenting the cascaded if statement avoids the problem of excessive indentation when the number of tests is large. Moreover, it assures the reader that the statement is nothing more than a series of tests. Keep in mind that a cascaded if statement isn't some kind of new statement. It's just an ordinary if statement that happens to have another if statement as its else clause, and that if statement has another if statement as its else clause, and so on and so on. Calculating a broker's commission program. When stocks are sold or purchased through a broker, the broker's commission is often computed using a sliding scale that depends on the value of the stocks traded. Let's say that a broker charges the amount shown in the following table. So you have these transaction sizes and these commission rates for the following transaction sizes. The minimum charge is $39. Our next program asks the user to enter the amount of the trade, then displays the amount of the commission. Enter the value of the trade, $30,000. The commission would be $166. The heart of the program is a cascaded if statement that determines which range the trade falls into. Broker.c calculates a broker's commission. Include standard io.h, int main void. We have a float commission and value variables. We call printf to enter a value of a trade, and we scan f and receive that float value into the value variable. If the value variable is less than 2500 float, then the commission is 30 plus the 17% of the value, right? Or 1.7%, I'm sorry. If the value is less than 2500 float, the commission is equal to 30 float plus 1.7% of the value. And we have these other else if conditional statements to evaluate the other values in the table. If commission is less than $39, the commission is $39 as a final catch. Printf commission is a float rounded to 2 values in commission. No, and we printf commission with a float with 2 decimal places and insert commission. I don't think there's a round that takes place. The cascaded if statement could have been written this way instead. The changes are indicated in bold. If value is less than 2500, then commission is this. Else if value greater than or equal to 2500 float and the value is less than 6250, the commission is this. Else if the value is greater than 6250 and the value is less than 20,000, then the commission is this, and so on and so on. Although the program will still work, the added conditions aren't necessary. For example, the first if clause tests whether value is less than 2500, and if so on. For example, the first if clause tests whether the value is less than 2500, and if so, computes the commission. When we reach the second if test, value greater than or equal to 2500 float, and value is less than 6250, we know that the value can't be less than 2500 and therefore must be greater than or equal to 2500. The conditional value greater than or equal to 2500 will always be true, so there's no point in checking it. The dangling else problem. When if statements are nested, we've got to watch out for the notorious dangling else problem. Consider the following example. If y does not equal 0, if x does not equal 0, then the result is x divided by y. Else print error y is equal to 0 in the first condition. To which if statement does the else clause belong to? The indentation suggests that it belongs to the outer if. However, C follows the rule that an else clause belongs to the nearest if statement that has already been paired with an else. In this example, the else clause actually belongs to the inner if statement, so a correctly indented, oh my gosh, so a correctly indented version would look like this. If y does not equal to 0, if x does not equal to 0, result equals to x divided by y, else printf error y is equal to 0. Right, to make it pair with this one. But this statement does not really make sense for that. To make the else clause part of the outer if statement, we can enclose the inner if statement in braces. This example illustrates the value of braces. If we'd used them in the original if statement, we wouldn't have gotten into this situation in the first place. Okay. So let's do really quickly the dangling else problem. So we'll say else statements pair with the nearest if statement when not deliberately used, when braces are not used, when curly braces are not used to distinguish order. Something like this. Some feedback here. And see, if when you have nested if statements without braces, and else is automatically paired with the nearest unmatched if above it. When you have nested if statements without braces, and else is automatically paired with the nearest unmatched if above it. So let's take this example. Let's copy this. Say example. Let's take this guy here. So this would be, we would say, the else belongs to the inner if. The inner if statement. But our string, print string, reflects the outer variable conditional check. So this would be wrong. Yeah. So then you can just put in these braces to deliberately section off the areas. Cool. You can only use indents for one inner else. It's one inner for one liner if else statements. Okay, cool. The orb can show you the beauty of almond. If an if else statement has more than one line, you need braces. There's a round with point two. Oh, okay, there's a round. I thought it just displayed because I had some instances I thought where it wasn't rounding, but whatever. You know how common it was for the dangling else to be written in this textbook? Yeah, it's funny. Okay, Let's keep chugging. Conditional else. Oh my gosh, conditional expressions. Let me go refill my water. Okay. Let's keep chugging. Conditional expressions. C's if statements allow a program to perform one of two actions depending on the value of a condition. C also provides an operator that allows an expression to produce one of two values depending on the value of a condition. The conditional operator consists of two symbols, question mark and colon, which must be used together in the following way. Expression 1, expression 2, and expression 3 can be expressions of any type. The resulting expression is said to be a conditional expression. The conditional operator is unique among C operators in that it requires three operands instead of one or two. For this reason, it is often referred to as a ternary operator. The conditional expression, expression 1, question mark, expression 2, colon, expression 3, should be read if expression 1, then expression 2, else expression 3. The expression is evaluated in stages. Expression 1 is evaluated first. If its value isn't 0, then expression 2 is evaluated, and its value is then the value of the entire conditional expression. If the value of expression 1 is 0, then the value of expression 3 is the value of the conditional. The following example illustrates the conditional operator. Int I, j, and k. I is equal to 1, j is 2, and k is equal to I greater than j, and k is equal to, if I is greater than j, then I should be said if, then, else. If you evaluate what? So this says k is equal to I greater than j if I is greater than j, then I else j. Oh, got you. If I is greater than j, then I else j. K is equal to, okay, so let's restart this. Int I j k. I is equal to 1, j is equal to 2, and k is equal to, if I is greater than j, then k is equal to I, else k is equal to j. So because I is less than j, k will evaluate, this will evaluate to 0 for false, so j will take place as the value of k, which is 2. Now we have another statement. K is equal to, parentheses, if I is greater than or equal to 0, then I, else 0. And then after we do that conditional, we add j. So if I is greater than or equal to 0, which it is, so this returns a value of 1. So we're going to do this conditional right here, then k is equal to I. So k is equal to 1. Then we add j, which is 2, so k in this statement becomes 3. The conditional expression I greater than j, then I else j in the first assignment to k returns the value of either I or j depending on which one is larger. Since I has the value of 1 and j has the value of 2, oh my dude, what is wrong with me? Like, I feel like such an idiot. Like, I can't even read. I think it's just because it's just a lot. It's hard to keep, like, it's like after like 5 or 6, 7 pages, it starts to get really like fuzzy. The conditional expression I greater than j, then I else j, in the first assignment to k returns the value of either I or j, depending on which one is larger. Since I has the value of 1 and j has the value of 2, then I greater than j comparison fails, and the value of the conditional is 2, which is assigned to k. In the second assignment to k, I greater than or equal to 0 comparison succeeds. The conditional expression I greater than or equal to 0, then I else 0 has the value of 1, which is then added to j to produce 3. The parentheses are necessary, by the way. The precedence of the conditional operator is less than that of the other operators we've discussed so far, with the exception of the assignment operators. Conditional expressions tend to make programs shorter but harder to understand, so it's probably best to avoid them. There are, however, a few places in which they are tempting. One is the return statement. Instead of writing if I is greater than j, return I, else return j, many programmers would write this: return I greater than j, then I else j. Calls to printf can sometimes benefit from condition expressions. Instead of if I is greater than j, print I, else print j, we could simply write print I greater than j, then I else j. Dude, yeah, this syntax is definitely tricky to kind of read. Even I'm getting a little tripped up here. It's my first time for sure. Gotta give myself some slack, but even just kind of reading it, it's like my brain's having to kind of like interpret the symbols, and it's definitely trippy to read here. We could simply write printf and insert a integer value, where we would insert the value of the conditional for I is greater than j, then I else j. Conditional expressions are also common in certain kinds of macro definitions. Okay, so let's quickly jot down some stuff on some conditional expressions. It's annoying when I make mistakes though while I read, because it makes it so annoying to edit. Like, I'm trying to be fluent with when I read, and fluid, because it's so much easier to just let the video play. But every time I have to chop and stuff, it sucks. Okay, so C's if statement allows a program to perform one of two actions depending on the value of a condition. C also provides an operator that allows an expression to produce one of two values depending on the value of a condition. The conditional operator consists of two symbols, this and this, which must be used together in the following way. The resulting expression is said to be a conditional expression. So, are these just in general, or are these just the specific type? It's a shorthand way to write, okay, yeah. It's just a specific type. So a shorthand way to write if-else statements that returns a value. So then we have this example here, this guy. Let's just do example expression 1, then expression 2, else expression 3. Right. So then we have the conditional operator consists of two symbols, this and this, which must be used together in the following way. And then we'll go here, put this here, I guess. Consists of two symbols, this and this, which must be used together in the following way. Can be expressions of any type, is unique to C, it's three operands, for this reason it's referred to as a ternary operator. Requires three operands instead of one or two. Really? Instead of two, often referred to as a ternary operator. Cool. It should be read this. Should be read this. Oh. Whatever. Should be read, quote, if expression 1, then expression 2, else expression 3. If its value isn't 0, then expression 2. Cool. So let me go ahead and just copy like this kind of code snippet here for an example. Throw this guy like here. Nice. Awesome. My C course did not allow if-else indents because it's hard to find bugs. Oh, wow. So you had to use braces for all indents, or for all if-else statements? Arrow? Modern IntelliSense will give a squiggly line. Hey, engineer, he's at it again. I love the ternary operator. The engineer maybe says, you're doing good, you will become a 10x nerd in no time. Thanks, dude. Yeah, we're getting the beard. We're going out the neck beard for it, for sure. Thank you for coming in. Okay, Boolean values in C89. For many years, the C language lacked a proper Boolean type, and there is none defined in the C89 standard. This omission is a minor annoyance since many programs need variables that can store either true or false. One way to work around this limitation of C89 is to declare an int variable and then assign it either 0 or 1. Int flag, flag equals 0, flag equals 1. Although this scheme works, it doesn't contribute much to program readability. It's not obvious that flag is assigned to be only Boolean values and that 0 or 1 represent false. It's not obvious that flag is assigned only, oh my goodness. It's not obvious that flag is to be assigned only Boolean values and that 0 and 1 represent false and true. To make programs more understandable, C89 programmers often define macros with names such as true and false. Define true 1, define false 0. Assignments to flag now have a more natural appearance. Flag equals to the value of false and flag equals to the value of true. To test whether flag is true, we can write if flag is equal to true or just if flag. The latter form is better not only because it's more concise but also because it will still work correctly if flag has a value of either 0 or 1. To test whether flag is false, we can write if flag is equal to false or if not flag. Carrying this idea one step further, we might even define a macro that can be used as a type. Define bool int. Bool can take the place of int when declaring Boolean variables. Bool defined on our flag variable. It's now clear that flag isn't an ordinary integer variable, but instead represents a Boolean condition. The compiler still treats flag as an int variable, of course. In later chapters, we'll discover better ways to set up a Boolean type in C by using type definitions and enumerations. Boolean values in C99. The long-standing lack of Boolean types has been remedied in C99, which provides the _bool type. In this version of C, a Boolean variable can be declared by writing _bool flag. _bool is an integer type, more precisely an unsigned integer type, so _bool variable is really just an integer variable in disguise. Unlike an ordinary integer variable, however, a _bool variable can only be assigned 0 or 1. In general, attempting to store a non-zero value into a bool variable will cause the variable to be assigned 1. Flag is equal to 5. Flag is assigned 1. It's legal, although not advisable, to perform arithmetic on bool variables. It's also legal to print a bool variable. Either 0 or 1 will be displayed. And of course, a bool variable can be tested in an if statement. If flag tests whether flag is 1. In addition to defining bool type, C99 also provides a new header, standard bool.h, that makes it easier to work with Boolean values. This header provides a macro, bool, that stands for the bool _type. If standard bool.h is included, you can write just bool flag, the same as _BOOL flag. The standard bool.h header also supplies macros named true and false, which stands for 1 and 0 respectively, making it possible to write flag is equal to false and flag is equal to true. Because the standard bool.h header is so handy, I'll use it in subsequent programs whenever Boolean variables are needed. Okay, cool. Hey Lance, how's it going? Seem to be working very hard. Yeah, we're trying to. I'm just having fun though. Honestly, it's a lot of fun. Like I'm not really like working like hard. I'm just like it's like having fun, kind of disguised as like hard work. It's like killing two birds with one stone because I'm also providing content for you guys and growing the channel and providing these notes and stuff and also studying. You know what? It's cool. Okay, so we have Boolean values in C89 here, which aren't really that important to us, but we should probably know about how this was set up. Boolean values in C89. Like a proper Boolean, there's many defined in C89. There is no Boolean type. There is no Boolean type defined in C89. So you can define a variable as an int and assign it either 0 or 1. Right, this is not very readable, and values that are non-zero or non-1 values that are not allowed or not allowed can still be assigned on accident. Right? It's not obvious that flag is assigned to be Boolean values of 0 or 1. So you can define macros. So define macros Right, we're going to define macros with names such as true and false. So we'll take this. Find true. Right. Now you can set flag equal to true, which now flag has a value of 1. Cool. So then you can define a bool. You can even define a custom type masked as a int, a custom bool type masked as an integer. So you could have like define bool int. Bool can take the place of int when declaring Boolean values, which we can do like, now we can do bool flag, which assigns flag a variable now is defined as a bool which acts as an int under the hood to only int under the hood. So then we have Boolean values in C99. So the long-standing lack of Boolean types has been remedied in C99, which provides the type this. C99 provides the underscore bool type. So you can do we'll go down here and do an example here. This will be underscore bool flag. Bool is an integer type, more precisely unsigned integer type. So let's go really quickly and do this. Underscore bool is an integer type, more precisely unsigned integer type. So many bool variables are really just an integer variable in disguise. An integer type, more precisely unsigned, so a underscore bool variable is really just an integer variable in disguise. Unlike an ordinary integer variable, however, it can only be assigned a value of 0 or 1. Can only be assigned a value of 0 or 1. In general, attempting to store a value greater than 1, the non-zero value will default to 1. So example. So bool flag. This will let me say flag is equal to 5, right? Flag, the variable flag is of type bool and has a value of 1. It's legal, not advisable to perform arithmetic. It's also legal to print a bool value. It can be tested with an if statement. So then we can do can be tested with an if statement. We'll do an example here. If flag this will test whether flag is 1. In addition to defining the underscore bool type, it provides a new header. So header file added. We'll do this. Standard bool.h header file. A header file added with macro definitions for bool readability. So it has like provides the bool a macro that equals bool for easier. Okay. It also provides macros named true or false in all lowercase. True and false. A macro which equates to a value of 1, and a macro which equates to a value of 0, right? Respectively. So then we can say, like, example would be flag is equal to false. Or sorry, this would be true. And then we could take this one, do an example here of false. Nice. It's so handy that I'll use it for the rest of the statements. Cool. Awesome. If you guys are enjoying the stream so far, if you could leave a like on it, I really appreciate you guys being here and hanging out with me so far. If you guys aren't subscribed, if you could subscribe and consider doing so, that'd be awesome. Okay, what page are we on? 86. Okay, probably go for another half hour here, so. Okay, 5.3, the switch statement. All right, cool. Hey, what's going on, Cristiano? Appreciate you for joining me. 5.3, the switch statement. In everyday programming, we'll often need to compare an expression against a series of values to see which one is currently matches. We saw that in section 5.2 that a cascaded if statement can be used for this purpose. For example, the following cascaded if statement prints the English words that correspond to a numerical grade. If grade is 4, print excellent, else if grade's 3, print good, else if grade's 2, print average, else if grade's 1, poor, else if grade's 0, print failing, else illegal grade. As an alternative to this kind of cascading if statement, C provides the switch statement. The following switch statement is equivalent to our cascaded if. Switch grade. Case 4, print excellent, break. Case 3, print good, break. Case 2, average, break. Case 1, print poor, break. Case 0, print failing, break. Default, print F, illegal grade, break. When this statement is executed, the value of the variable grade is tested against 4, 3, 2, 1, and 0. If it matches 4, for example, the message excellent is printed. Then the break statement transfers control to the statement following the switch. If the value of the grade doesn't match any of the choices listed, the default case applies and the illegal grade is printed. A switch statement is often easier to read than a cascaded if statement. Moreover, switch statements are often faster than if statements, especially when they are more than a handful of cases. In its most common form, the switch statement has the form of switch, expression we're evaluating, case, constant expression statements, case, constant expression statements, default, and then the statement. Hey, thank you, Cherry. Thank you so much for the follow on Twitch. You're awesome. The switch statement is fairly complex. Let's look at its components one by one. Controlling expression. The word switch must be followed by an integer expression in parentheses. Characters are treated as integers in C and thus can be tested in switch statements. Floating point numbers and strings don't qualify, however. Case labels. Each case begins with the label of the form case and constant expression : A constant expression is much like any ordinary expression except that it can't contain variables or function calls. Thus, 5 is a constant expression, and 5 plus 10 is a constant expression, but n plus 10 isn't a constant expression. Thus, 5 is a constant expression, and 5 plus 10 is a constant expression, but n plus 10 isn't a constant expression unless n is a macro that represents a constant. The constant expression in a case label must evaluate to an integer. Characters are also acceptable. Statements. After each case label comes any number of statements. No braces are required around the statements. Enjoy it. This is one of the few places in C where braces aren't required. The last statement in each group is normally break. Duplicate case labels aren't allowed. The order of the cases doesn't matter. In particular, the default case doesn't need to come last. Only one constant expression may follow the word case, however. Several case labels may precede the same group of statements. Switch grade. Case 4 has nothing, case 3 has nothing, case 2 has nothing, case 1 does something, case 0 does failing, and with a default. To save space, programmers sometimes put several case labels on the same line. Case 4, 3, 2, 1 prints passing, case 0 prints failing, and default is illegal grade. Unfortunately, there's no way to write a case label that specifies a range of values, and there's in some programming languages. Unfortunately, there is no way to write a case label that specifies a range of values as there is in some programming languages. A switch statement isn't required to have a default case. If default is missing and the value of the controlling expression doesn't match any of the case labels, control simply passes to the next statement after the switch. The role of the break statement. Now let's take a closer look at the mysterious break statement. As we've seen, executing a break statement causes the program to break out of the switch statement. The role of the breakout statement. Now let's take a closer look at the mysterious break statement. As we've seen, executing a break statement causes the program to break out of the switch statement. Execution continues at the next statement after the switch. The reason that we need break has to do with the fact that the switch statement is really a form of computed jump. When the controlling expression is evaluated, control jumps to the case label matching the value of the switch expression. A case label is nothing more than a marker indicating a position within the switch. When the last statement in the case has been executed, control falls through to the first statement in the following case. The case label for the next case is ignored. Without break or some other jump statement, control will flow from one case into the next. Consider the following switch statement. Case 4, print excellent, and so on and so on and so on with no breaks. If the value of the grade is 3, the message printed is good, average, poor, failing, and a legal grade, so everything that comes after 3. Forgetting to use break is a common error, although omitting break is sometimes done intentionally to allow several cases to share code. It's usually just an oversight. Since deliberately falling through from one case into the next is rare, it's a good idea to point out any deliberate omissions of break. Switch, grade, with case 4, case 3, case 2, and case 1, num passing plus plus, and we fall through to case 0, total grades plus plus, and break. Without the comment, someone might later fix the error by adding an unwanted break statement. Although the last case in a switch statement never needs a break statement, it's common to practice. Although the last case in a switch statement never needs a break statement, it's common practice to put one there anyways to guard against a missing break problem if cases should later be added. Program. Printing a date in legal form. Contracts and other legal documents are often dated in the following way. Dated this blank day of blank 2000 and blank. Let's write a program that displays dates in this form. We'll have the user enter the date in month, day, and year form. Then we'll display the date in, quote, legal form. Enter date in month, day, year form. So 7/19/2014 or 7/19/14. Dated this 19th day of July 2014. We can get printf to do most of the formatting. However, we are left with two problems. How to add th or st or nd or rd, that suffix, to the day, and how to print the month as a word instead of a number. Fortunately, the switch statement is ideal for both situations. We'll have one switch print the day suffix and another print the month's name. Date.c prints a date in legal form. We include the standard io.h in our main function with 0 parameters and returns an integer. We declare integers of month, day, and year, and we enter the date with a printf statement in this format. We receive the date with a scanf that takes in the integer values into month, day, and year, and we printf dated this day %d for day. We have a switch statement for the day variable to evaluate the day variable for the case 1, case 21, and case 31. We're going to printf st. So 1st, 21st, 31st. In the case of 2 or 22, we print nd for second or 22nd. Case 3 would be the 3rd or 23rd. And the default would be to printf to the th, would be like the 5th day. And we print day of, then we have a switch on the month, and we have all of these cases for the months of the year, January through December, for corresponding to the integer values of those months, 1 through 12, in the case statements. We then printf to the year with a 20 in front of it and two values of the year. and return 0. Note the use of %.2d to display the last 2 digits of the year. If we had used %d instead, single-digit years would be displayed incorrectly. 2005 would be printed as 205. And Q&A here. Q&A. Question. My compiler doesn't give me a warning when I use equals to instead of is equals to. Is there some way to force the compiler to notice this problem? Here's a trick that some programmers use. Instead of writing if I is equal to 0, they habitually write if 0 is equal to I. Now suppose that the is equal to operator is actually written as equals to. If 0 equals I, the compiler will produce an error message since it's not possible to assign a value of 0. The compiler will produce an error message since it's not possible to assign a value to 0. I don't use this trick because I think it makes programmers look unnatural. Also, it can be used only when one of the operands in the test condition isn't a L value. Fortunately, many compilers are capable of checking for suspect uses of the equals to assignment operator in if conditions. The GCC compiler, for example, will perform this check if the -w parentheses option is used or if the -wall all warnings is selected. GCC allows the programmer to suppress the warning in a particular case by enclosing the if condition in a second set of parentheses. Question. C books seem to use several different styles of indentation and braces placement for compound statements. Which style is best? According to the New Hacker's Dictionary, there are 4 common styles of indentation and brace placements. The K&R style, used in Kernighan and Ritchie's The C Programming Language, is the one I've chosen for the programs in this book. In the K&R style, the left brace appears at the right. In the K&R style, the left brace appears at the end of a line. The K&R style keeps programs compact by not putting the left brace on a line by itself. A disadvantage, the left brace can be hard to find. I don't consider this a problem since the indentation of the inner statements makes it clear where the left brace should be. The K&R style is the one most often used in Java, by the way. The Allman style. After Eric Allman, the author of SendMail and the Allman style. Jeez, dude, I've been reading a long time. The Allman style, named after Eric Allman, the author of SendMail and other Unix utilities, puts the left brace on a separate line. This style makes it easy to check that braces come in matching pairs. The Whitesmith style, popularized by Whitesmith C compiler, dictates that braces be indented. Ooh. The GNU style, used in software development by GNU project or GNU project, indents the braces, then further indents the inner statements. Which style you use mainly a matter of taste. There's no proof that one style is clearly better. Which style you use is mainly a matter of taste. There's no proof that one style is clearly better than the others. In any event, choosing the right style is less important than applying it consistently. Question. If I is an integer variable and f is a float variable, what is the type of the conditional expression I is greater than 0, then I, else f? When int and float values are mixed in a conditional expression, as they are here, the expression has a type float. If I is greater than 0 is true, the value of the expression will be a value of I after conversion to float type. Why doesn't C99 have a better name for its Boolean type? Underscore capital BOOL isn't a very elegant name, is it? More common names such as lowercase bool or boolean weren't chosen because existing C programs might already define these names, causing older code not to compile. Okay, so why wouldn't the name underscore bool break older programs as well? The C89 standard specifies that names beginning with an underscore followed by an uppercase letter are reserved for future use and should not be used by programmers. The template given for the switch statement describes it as the most common form. Are there other forms? On page 87. The switch statement is a bit more general than described in this chapter, although the description here is general enough for virtually all programs. For example, a switch statement can contain labels that aren't preceded by the word case, which leads to amusing question mark trap. Suppose that we accidentally misspelled the word default. The compiler may not detect the error since it assumes the default is an ordinary label. Question: I've seen several methods of indenting the switch statement. Which way is best? Answer: there are at least two common methods. One is to put the statements in each case after the case label, like so. If each case consists of a single action, a call of printf in this example, the break statement could even go on the same line as the action. The other method is to put the statements under the case label, indenting the statements to make the case label stand out. In one variation of this scheme, each case label is a line under the word switch. The first method is fine when the statement in each case are short and there are relatively few of them. The second method is better for large switch statements in which the statement in each case are complex and or numerous. Woo! Let's go. All right, let's quickly get some notes on the switch statement really fast. And then we'll be good to go here for today. That was a lot of reading today. Jeez Louise. 2 hours of reading. So it can be used for this purpose. And so we'll say here the switch statement, right, is an alternative to the cascaded if statement. C provides a switch statement. This is equivalent to a cascaded if. Copy this image. When it's executed, the variable grade, so we'll say the variable grade is tested against 4, 3, 2, 1, and 0 if it matches a value. The actions within the actions followed by the colon within the case statement are performed. A switch statement is often easier to read than cascaded ifs, so it kind of follows this general format. Image here. Expression, case, constant expression, statement. So if the value matches actions followed, the statements followed by the performed. So then we have this, and we have controlling expression. The word switch must be followed by an integer expression in parentheses. Characters are treated as integers in C and thus can be tested in switch statements. So we'll take pretty much this whole thing. The word switch must be followed by an integer expression in parentheses. Characters are treated as integers in C and thus can be tested in switch statements. Floating point numbers and strings don't qualify, however. Case labels. Just do this really quickly. each case begins with a label of the form. And then we'll do this, case, constant, expression, colon. A constant expression is much like an ordinary expression. So we'll say constant expression. So a constant expression is much like an ordinary expression. It can't contain variables or function calls. Much like an ordinary expression, except that it can't contain variables or function calls. Then we'll also take this one. The constant expression in a case label must evaluate to an integer. So we'll say, we'll come here and go like this and go example, and then paste this. So we'll say 5 is a constant expression. 5 plus 10 is a constant expression, but n plus 10 isn't, unless n is a macro that represents a constant. And then lastly, we have here statements, right? After each case label comes any number of statements. No braces are required around the statements. The last statement in the group is normally a break. Okay. Cool. Duplicate labels aren't allowed. The default case doesn't need to come last. So we'll say like order doesn't matter. Whatever, that's fine. No way to write case associated range of values. Okay. Now let's take a look at the closer look at the mysterious break statement. As we've seen, executing a break statement. So we'll say, go here and go the role of the break statement. So we'll say, let's take a closer look at the break. Executing a break statement causes the program to break out of the switch statement. Executing condition continues here. Switch statement execution continues in the next statement after the switch. Okay, the reason we need to break has to do with the fact that the switch statement is really a form of a computed jump. When the controlling expression is evaluated, control jumps to the case label matching the value of the switch expression. A case label is nothing more than a marker indicating position within the switch. When the statement of the case has been executed, the control falls through to the first statement in the following case. The case label for the next case is ignored. Without break or some jump statement, control will flow. Honestly, this is like a really good paragraph. So I'm going to take this whole thing pretty much. So we say the reason that we need the break statement has to do with the fact that switch oh gosh. Statement is really a form of a computed jump. When the controlling expression is evaluated, control jumps to the case label matching the value of the switch expression. A case label is nothing more than a marker indicating a position within the switch. It falls through to the first statement in which the following case, the control case for, is ignored. Without the break or some other jump statement, control will flow from one case into the next. So then I'm going to take this example here. And then we'll do an example and throw that guy there. Okay, cool. Nice. I think that's probably it for the notes of this chapter. Holy Moses. That was a lot. Chapter 5, selection statements, types of selection statements. We went over some logical expressions, less than, greater than, less than or equal to, greater than or equal to. Operator equality is equal to and not equal to expressions or operators. We learned about logical operators for combining logic and performing logic in statements. Then we learned about if statements, where we can evaluate if conditionals across various expressions and perform statements that happen across those evaluations. We learned about else blocks as well that are paired with those, and else ifs that you can use in unison to have that cascading if chain. We learned about dangling else problems, where else blocks are localized to the scope of the nearest if statement. So if you don't have braces appropriately, segregating out your code chunks, then the else block could correspond incorrectly to an if statement that you might not know of or be planning of. We talked about conditional expressions, which are shorthand forms to write if-else statements. So you can use this question mark and colon to evaluate an initial expression. So expression, if expression, then this, else this. We learned about Boolean types in C89 and C99, where Boolean types weren't really present in C89, so you kind of had to make your own with these custom definitions through macro types and just kind of trusting that zeros and ones were in the correct form. Whereas in C99, we added this underscore Boolean type, and then this takes in also a standard Boolean header file that inherits this bool macro to be used, which is commonly used with true and false as well for 0 or 1 forced use, right? We then introduced a switch statement, which is similar in Python to our match case, where we have a switch for overall, we're going to basically determine a bunch of evaluations, case evaluations for a single variable. Or whatever it would be up here. I think we can do pretty much any expression, right? Yeah. So we can match any expression condition, and if that is true, for any of the following cases that happen. And we can perform those. And these cases need a break statement, or they fall through. And any case that has evaluates to true in this case could take place for all of if we don't break out. And yeah, that was kind of the gist of it here. Cool. Hey, Cristiano, arrow Python is something similar to the keyword match. Yeah, exactly. Pattern matching, match cases. Yeah, exactly. I like using match case in Python. I often use that one more than if-else chains because it's just easier to read, honestly. It's a little bit more difficult, it's honestly kind of a little bit more keystrokes to set up, but it's pretty easy to read. Putting multiple cases on the same line is disgusting. Where was that at? Where did they do that at? Oh, here. W. Allman. Almond style is usually used in production C, which is where we put the parenthesis or we keep the brackets in line with the if statement, but we move the bracket to a new line. I don't think you can declare new variables inside case statements, though. Dimitri says you can, but you'd better put the body of a case label inside a bracket, not avoid name collisions. C++ would emit errors if you won't put declarations of variables inside brackets, instead inside case labels, to avoid name collisions, I wanted to say in my previous comment. Cool. Awesome. So pat on the back for everybody joining me here for this reading of C Programming, A Modern Approach, Chapter 5. Thank you guys. Hold on, let's go up to the front of the chapter. Let's get up to the front of the chapter here. Cool. All right, thank you guys so much for joining me here for the reading and completion of... No, not completion. Thank you guys so much for joining me here for the reading of C Programming, A Modern Approach, second edition by K.N. King, Chapter 5, Selection Statements. This was a really awesome chapter kind of going over, those conditional statements and evaluations of those selection statements used in C. A lot of it is kind of consistent with what we learned in Python, but it added a lot of new operators that adds a lot more kind of niche functionality that you can do in C, which will be fun. Thank you guys so much for being here and joining me. I really appreciate you guys hanging out with me. Thank you guys so much. I'll see you in the next one. All right, that's the end of the recording. So hold on, we don't have to end the stream yet. Again, guys, that's the end of the recording. Okay, phew. That is over. How are we feeling out there? How are we feeling about the reading so far? Hey, what's going on, Protector? Welcome back in. All right, stop that recording. We're all good to go. Nice. Feels good. That was a long one. That took like 2 hours to get through. Let's get some hearts in chat. Hearts in chat. What do you guys think about this one so far? This one was fun. We kind of unlocked definitely some new skills. I'm excited to get into the practice problems. Let's take a little peek at what they'll look like. What are some of the exercises? Are they difficult? The following program fragment illustrates the relational inequality operators. Show the output produced by each, assuming that I, J, and K are int variables. Okay, so more output predictions. Output predictions. Write a single expression whose value is either -1, 0, or +1, depending on whether I is less than or equal to or greater than J. Cool, pretty easy. Is the following statement legal? Legal. Print statement. And then we have some programming projects here. So this one says, write a program that calculates how many digits are in the number. Oh, cool. Write a program that asks the user for 24-hour time and displays it in 12-hour form. Modify the broker.c program by making both the following changes. Ask the user to enter the number of shares and the price per share. Okay, cool. So it really it's going to ramp up here quick, you guys. These examples are starting to, they're not getting too difficult, but just in the amount of effort that's needing to actually complete the individual questions, it's starting to ramp up for sure. So it should be fun. I got a comment on one of my videos of earlier chapters that said that someone else had read this book and that after the questions in chapter 9 were like, that it like wrecked them, that like weeded them out. And so we're looking forward to later chapters. The questions apparently get pretty difficult to complete. So I'm looking forward to that. I will join your streams much often if it wasn't for the time zone disparity. Oh, sorry, dude. When you stream, it's like 3 to 4 a.m. for me. Oh, man, I'm sorry. Yeah, that's tough. I streamed last night at from like 2 a.m. to like 5 a.m. last night. Can you tell me what the book is? Yeah, it's in the title. It's C Programming, A Modern Approach, 2nd edition. You can find more information in my Discord, Protector. I think you're in the Discord. What's going on here? Oh, it's just kind of lagging a little bit. All right, you guys. Cool. I really appreciate everybody joining me today and reading this chapter with me. I'm looking forward to diving into some of these practice problems and seeing what we can do. Um, I feel though, like honestly, I'm a little bit, we're not kind of neglecting our like projects and stuff. So I don't want to like forget all my Python stuff as well. So we do need to keep up with our projects as well as keeping going with the book. Honestly, I'm just pretty motivated to keep going with C because I'm pretty excited about it. I feel that it's really kind of fun to actually have more control. Like I'm being like my eyes are kind of being opened to the amount of control that I actually can have over these individual like data types and whatnot. Rather than just having an int, I need to like further declare the size of the int via long or like long on different operating systems or like it's really interesting how much control you can actually have if needed as a programmer, and it's like kind of like a lot of power, and with great power comes great responsibility or whatever. um, Obviously, like sometimes in Python it's fun to just kind of get things out quickly and whatnot, but I wonder for like large, bigger, maybe more complex programs that we could see if we could really utilize these data types and see what we could come up with. So I'm interested and curious, and let me know what you guys think. Um, what else should we do? Should we call it for today? If you guys haven't used any Linux operating systems, let me know what operating system you use or distro. I'm looking into getting into like a ThinkPad and getting Linux and having like a home server and kind of getting that going. Potentially like seeing what I could do, and um, I think it'd be kind of fun. So let me know if you're interested in that, and I think it'd be fun to dive into that and maybe start writing some C code onto our, if we need to, onto our servers or I don't know, dude. I have no idea. So we're gonna get into that soon. My goal is though to set up like an automated like garden. I think that'd be a cool project where I could like have a microcontroller and code up some stuff to automatically like detect humidity and temperature levels and turn on and like have an automatic timers and stuff for the lights and like fans and like maybe like a water spray system to like if humidity gets too low or whatnot. And I think it'd be really cool to like build like an automated garden system, and we could set it up in my closet or something. So I appreciate you guys being here and hanging out with me for today. Please message me on Discord if you have any questions or want to talk to me there. Please join the Discord. Please subscribe and like the video and the channel if you're interested in hanging out with me. I stream almost every single day, teaching myself computer science and programming from scratch. Um, yeah, we're going to continue on here. Let me go ahead and push up the code, the notes here. Git add, git commit, crewmit. Um, Finish reading notes. Ah. Eat bush. All right, cool. So my notes, these notes are live on my GitHub if you want to check them out. Reference back to them. It's it's a pretty cool place to just get like a good spark notes over what was in the chapter. Honestly, if you read through my notes, you'll probably like extract out like 95% of the juice that's in the chapter in a really short format. So like in only like 100 or so lines of text rather than reading 20 pages. So if you want to just quickly get through the material, definitely read through the notes, read them through a couple times, because it's really good, and I have good examples and pictures straight from the book, and I think it's really really cool. So in before Mike starts Linux racing. Racing, oh, it's funny. Car guys become the Linux guys, right? Racing cars. I think for home distros, you can choose something popular like Ubuntu or Mint. I personally use Arch just because I was interested in crafting my own OS from scratch. Does Arch have like support stuff for like home server stuff? I often people typically, right, don't they typically go with like Ubuntu or um, Fedora for like server because it has like kind of that build. I'm not sure. Like there's a lot of stuff, dude. There's so many like so much stuff, so many packages and all this yada yada. Let's look at this.
This is my ThinkPad T440p that I built a little while ago on this channel, and I absolutely love this thing. It's robust, it's fast, and it's been good in every single use case that I've ever thrown at it. It's awesome. Although there's a few issues I need to iron out with this thing. The first thing being this screen. Little reminder from last video on what this laptop was an upgrade from. My previous laptop was a 2012 MacBook Pro with the Retina display. And so far the ThinkPad is way better than that laptop in almost every way, except for the screen. The screen absolutely sucks. It's turbo shit. It's a TN panel and its viewing angles suck. And the resolution is 1366 by 768. Total downgrade from like the 1440p display that was on my old laptop. Yeah. And the other major problem I would say is the Wi-Fi. Now, I'm not exactly picky when it comes to like having the newest Wi-Fi standards or anything like that, but at least having 5
I was thinking like we get like nice. I was thinking like a T490S or something like that, or maybe we get like an X1 Carbon or like something. I definitely think we go i7, 16 gigabytes RAM, at least 256 gig SSD that I can upgrade later. Right. Or I can like put it on a dock and have my dock hooked up to a couple of drives, or something like that. But what kind of model do you think we should do?
Nice. There's also a couple upgrades and quality of life improvements that I would like to add to this thing as well, including a new, really cool CPU and Libre boot.
This is IONIC1K.
Good evening.
Alright, so, first order of business, let's get that darn screen replaced. As I said before, the old screen was a 1366 by 768 TN panel. It's not very great, yeah, you get the point. So here's the new screen I bought. This is the Innolux N140HCG-GQ2. This is a IPS 1920 by 1080 panel. It can display 16.7 million colors, so native 8-bit. It has an 800:1 contrast ratio with a 14 millisecond response time, 89-degree viewing angle, peak brightness of 400 nits, and consumes
what
only
are like the models like?
This is a much,
what's like the difference
much
between
bigger
like
upgrade compared to what I had before.
Well, is the recent
the
models
old
like
TN
T
panel
or is
has
that
a
what's
500:1
like
contrast ratio, can do 262,000 colors, has a peak brightness of about 220 nits, with a consumes 300 milliwatts, a little part of fully and gently careful of that 30, where I got a little confused. While looking at the old screen, you can very clearly see where you're supposed to screw it in. But on the new screen, there's no screws anywhere on the corners. One thing I noticed while I was unboxing the screen though, is it came with these what looked like to be adhesive strips. And that right there is when I connected the dots and I was like, oh, really? So you don't screw the new screen in, you're supposed to use these adhesive strips and basically adhere it to the back of the lid, which I really do not like. So I went ahead, plugged in the connector, and I applied the adhesive strips and I put it in there. And while it does work fine, I do find it to be incredibly janky. So I don't know, if you're gonna buy a replacement screen for your T440p, maybe find one that you can actually screw in instead of the adhesive. But anyway, so I booted up the laptop.
I mean,
and
it's getting clamped
right
into the shell though, so it's not like it's gonna go anywhere.
As soon as I saw the Lenovo logo, damn, this thing looks awesome. It's so smooth, and you can basically view it at whatever angle. It doesn't matter.
We gotta get a
I also really noticed the difference between the color and the contrast as well. It just all around looks better, and it feels better. The footage I'm showing right now to display the screen is some camcorder footage.
Has a $2,000 MacBook Pro. Yeah, we gotta get a ThinkPad, you guys.
So the next thing on the list is Libre boot. So Libre boot is an open source BIOS replacement, and it is a distribution of something else called Coreboot. While Coreboot is also pretty good on ThinkPads, you want to use Libre boot mainly because of its open source memory initialization, and by default having no proprietary code blobs. You will have to add them if you want things like gigabit Ethernet, and those are called vendor files. Now I'm doing this for two reasons. One, I want to completely gut the Intel management engine, more on that later. And two, I'm doing this because you have to install the new Wi-Fi card that I bought. There's a few other features with this kind of software that can make it kind of cool and appealing. For example, LibreBoot and coreboot both have the ability to store payloads within the BIOS ROM, and with the payloads you can have memtest64 in your BIOS, you could put a grub payload in your BIOS, so then you can fully encrypt your hard disks. There's a payload called U-Boot, which is a fully functional UEFI bootloader, and there's a couple fun things like Doom as a payload that you can load into the BIOS, and you can also inject Doom wads into the BIOS, and you can play Doom in your BIOS. Maybe that's something for another video. I also want to completely gut the Intel management engine. Now, I went into some brief detail about this in my last ThinkPad video, but for just a quick rundown, Intel ME, while having other actual legitimate use cases, is an embedded microcontroller that resides on your motherboard's chipset that is literally a backdoor into your computer. It has direct memory access, it has access to the frame buffer, meaning that it can see the things that are on your screen, and it can access your hard disks. Intel ME even boots its own kernel. It is a very heavily modified version of the microkernel Unix-like operating system known as Minix, and this is what it uses for its network stack and a bunch of other stuff. Now, this is here for governments to take advantage of this and to get backdoors into people's computers, but there are some legitimate use cases for ME as well. Like, for example, imagine this machine belongs to an organization. You can tie it to an Intel Management Engine server, so essentially if this laptop gets stolen, you can mark it as stolen on the server, so the second that it gets internet connection again, it can essentially brick the laptop, and some other business management stuff. Now, technically that stuff is marketed underneath vPro, but it still uses the management engine to achieve a lot of that. Intel ME first shipped on the Intel 965 Express chipset family, which was introduced in June 2006, and got fully adopted in 2008. So basically that chud sitting at home with the 12700K also has ME. It's not just a laptop thing. Now, AMD has their own similar thing called AMD PSP. Now, while I really still don't like it, I think it's a lot less spooky than Intel Management Engine, because PSP does not have the ability to connect to a network. Now, apart from being schizophrenic and thinking that the government is watching me, even though I have nothing to hide, there has been a lot of use cases where this feature has been tampered with and used to basically gain access of your computer. So basically what this is going to do, I know I said completely gut the ME region, but that's not really how that works. There are some older ThinkPads where you can completely gut the ME firmware and nothing happens. But in my case, if I gut all the ME firmware, the machine will appear to work, but it will shut itself off after 30 minutes because it doesn't see any proper firmware. So essentially what this configuration is going to do, ME will be active on startup during the BIOS initialization, but then after the initial BIOS initialization and boot process, ME will no longer be active. Basically meaning that whenever I get into the operating system, it's gone. And this way you can kind of spoof ME into thinking that it's still there and active, even though it's not. And also with this configuration, there's a lot more components of ME that are just neutered, so really it's not going to do anything. So this does involve me taking the entire laptop apart, or at least the bottom half of the chassis, so I can get access to two ROM chips. One is 8 megabytes and one is 4 megabytes. And I have to flash these both. And while flashing and everything like that is pretty easy, actually getting LibreBoot built is probably the shittiest thing I think I've ever had to do. Not because actually building it is hard, but the documentation just sucks. So here's my attempt of installing LibreBoot. You know, I was looking
So he's trying to install this different boot option so it bypasses the Intel, like, you know, basically like security features
earlier, and it's just like
chip.
I can't. What the fuck?
I know it sucks. Like that's why
kind of like jailbreaking the
how I was able to
the
get it
startup
installed because
almost.
the documentation is that.
Searching, I found the repo, and I went to dependencies, and there's auto downloads all my.
G. Man, to just delete
Yeah,
everything.
I know, but I forgot what it was. Wasn't it like D something like in the morning?
Ever created it, and they don't want to use a font. They're called.
Bro, that's funny, bro. I'm glad.
Cool. Let's see. ThinkPad. Linux. So, let's go recents. We gotta do some research. Alright, you guys. I think I'm gonna probably head out for today. Appreciate you guys hanging out with me. We read, like I said, chapter 5 of C Programming a Modern Approach and got to the exercises. We'll complete these in a different stream. But I really appreciate you guys hanging out with me and joining me for today. I'm super excited to learn more about C and start actually writing projects and managing our own memory and seeing what we can do, and really taking our programming to the next level apart from Python. Thank you guys so much for joining me today. Please leave a like if you did, and I'll make sure I'll have this probably uploaded. The chopped up version for chapter 5, I'll probably have it uploaded tomorrow. So I'll see you guys then. See you guys tomorrow. Have a great night. Bye.